Hi folks, Jack from Smoky Mountain Scientific. Today I want to give you a little introduction to working with EAGLE, CadSoft EAGLE, to Autodesk to do some design work for electronics. And this what I'm going to be working on is a project for getting humidity down in my garage, right? So I live in a place where there's so much humidity that I grow fungus on my plywood, and I want to get that down. Anyway, so I've got this old-fashioned dehumidifier that's kind of a dumb apparatus, and it doesn't have humidity sensing. So that's what I want to do. I want to have a control for the dehumidifier, and I also want to make it something I can monitor from inside the house here. All right, so let's talk a little bit about the design. So what we want to do is have a computer in the house, and we want to hook this up to a Raspberry Pi in the garage, and we want the Raspberry Pi to monitor the humidity, so we need a sensor. And then we have to have an output that's an input. Here's an output that turns on or off the dehumidifier. What we're going to use is a solid state relay, and that will turn the dehumidifier on. Okay, so the Raspberry Pi operates on 3.3 volts. Solid state relay will allow us to turn on or off the 110 volt AC. This is 3.3 DC to the dehumidifier. Okay, so we'll have the 110 to the dehumidifier, and then back to the wall circuit for that. So that's our basic diagram. And now what we're going to do is we're going to talk about the circuit that we're going to use. Okay. So what I want to do, I want to have a board that has the sensor, and the sensor that we want to use looks like the HTU31D humidity, relative humidity and temperature sensor from, I forgot the name of the company. Anyway, this has a sensor that operates on I2C, I2C. So the Raspberry Pi will give an I2C signal to the sensor. It's going to need a VCC and a ground connection, right? And then on the same board, we're going to have the terminals, the GPIOs connect to for the solid state relay, right? That'll just be a connection. We'll have another connection, one for the positive 3.3 and one for ground. All right, so that's what we're looking at, and now we'll talk a little bit about CadSoft EAGLE. Okay, so right now we're going to talk about making a footprint for this HTU31 relative humidity and temperature sensor. And so we're going to be able to put that on our circuit board, right? So I'm on the TE connectivity document page here, and this will tell us everything we need to know. Okay, so the first thing we need is on page 7. Let's just put that in there, 7. And this describes the pin assignment, right? So pin number 1, which is down here, is the serial data pin. Pin number 2 is ground. Pin number 3 is the address pin. And pin 4 is reset, 5 is your 3.3 volt supply voltage, and then we have our clock pin. Okay. One thing I noticed that this is kind of upside down. Usually you see pin 1 up here, and when I design the footprint in Eagle, I'm going to set it up that way. So I'm going to want this piece here, this thing that you see when you look at this, I want that on the bottom instead of on the top. You'll notice that there's also this thermal pad on the bottom, and I believe that's probably grounded, but it doesn't tell you that over here. All right, so we're not going to worry too much about that, but I'm going to make a little change when we set up when we set it up. All right, so let's go to page 17, which is where the land pattern for it, the footprint for it is. And this is kind of an odd looking thing, but what it does, it gives us all of the dimensions, right? So these pins are all 0.5 by 0.6 millimeters. The pad here is 1.5 millimeters wide. And once again, they put this thing kind of sideways. I'm going to turn it up. All right, so let's go to Eagle and see what we can do. All right, so here was Eagle as you just open it up, and we want to go to File, New. No, we want to Open Library, and there's the AJAC library. I put that A there so that it would show up early in the alphabetical listing. Okay, so what we're going to do is we are going to, first of all, let's make the footprint. And we're going to make a new footprint. It's going to be the footprint for the... Okay, so the package is DFN6. Okay. Create new footprint. Yes, we do. We do want to create the new footprint. All right, so the first thing, when you open this thing up, for some reason it's set up in inch settings. So we want to go in and change that. We go into the grid, and we want to change mils to millimeters, okay? And let's say we want to have our lines at, let's say 0.8 millimeters apart. That didn't give me a point, did it? 0.8. There we go. And that's all we need. So let's just say OK, and that gives us this. All right, so the first thing we want to do is draw some lines, okay? And our thing is going to be square, so we're just going to make a square or something as close to square as is needed. All right, now we're going to make this thing the right size. So we're going to hit the information button up here. We're going to select that one, and we need this thing to be 2.45 millimeters square. So what we're going to do is we're going to change the parameters up here. So instead of being minus 3.2 to plus 3.2, we're going to say minus 1.23. Let's say 1.23. 1.23, and we'll change all these numbers to 1.23. Get this one there, 1.23. This one over here, 1.23. Okay, apply that, and that's what it happens. Okay, now we're going to select this one, and we're going to do that 1.23 thing again. Now we have minus 1.23, and over here we have minus 1.23 and minus 1.23. Okay, we're just going to hit the apply button, and we are good. All right, there's the size and shape of our little guy. Let's zoom in a little bit. Okay, we need to have some footprints on it, some surface mount device pins. What the heck? How come that put on there? Anyway, we need 6 of these things. 1, 2, you know what? They have to be on that, don't they? Boom. Okay. And now we're going to change the size of them. And we're going to hit this change button. And we're going to go down to surface mount device. Okay. And we want these things to be, let's see, where are they? We want them to be 0.5 by 0.6. And let's see, probably do the X direction first. So we want that to be 0.6 by 0.5. Okay, so we'll come down here to those 3 dots, and we're going to give a new option, 0.6 by 0.5. And we'll say OK. And now we'll change the size of each of these by just clicking on the button, clicking on the pad. Okay. Now what we want to do is put them in the right spots. They're not in the right spots, and we're going to from the picture here on page 17. On page 17, we can figure out the X and Y coordinates, right? We want these things to be 2.46 millimeters apart, so that means that half of that is 1.23. Let's write that down. 1.23, and we want them 0.8 apart in the Y direction. So let's go back and do that. Okay, so information, boom. Okay, this guy here, we want him to be at the minus, what did we say, 1.23 as our X, and we want it 0 as the Y, and we'll do that same thing here. 1.23 with 0, okay, and we're going to make this one at 1.23 and 0.8, which is the position we got off of the something or other, off of the spec sheet. All right, let's see here. 1.23. You know what? We have not been naming these things. We'll get to that. Okay, so now the pins are in the right places. Oh, we forgot to put that big one on there, didn't we? All right, so that's going to be our thermal pad. And for some unknown reason, I'm going to be messing with that a little bit. So we want it to have a size of, oh, it doesn't let us change it here, does it? Huh. Okay. Cancel that. I want to go into that, change surface mount device. And we want to change that one to be 1.55. Damn it, get out of there. 1.55, and it's got to be at least 2.45 long. Let's say we want to have a full millimeter out. Well, I want to have a full meter out. So let's say 3.5. Okay. And we'll see what that does. Whoops. Invalid. Okay, so I did something wrong. SMD. Back down to here. And that was 1.55 width by 3.5. Enter. Okay. Now we do that. Boom, and it gets big. Okay, now what I want to do is move that up a little bit. And so we're going to make that 0.5. And what I want to do here, I want to have this thing sticking out, this pad sticking out, so I can solder on it when this thing, when the chip is on the circuit board, right? So yeah, you can do this with solder paste and a stencil, but I don't really feel like buying a stencil for this little project. Okay. All right, so let's get in here and let's make ourselves another line, and we don't want that on the top layer. We want that on, let's call it top document. Okay, and we're going to come in here, and you know what? I'm going to do it out here. Okay, now I'm going to change the position of that. Where do we want that thing? We want it to be right in here. That's going to show us which side is up, right? So when we do the information thing, what are we going to do? We're going to make that thing, it's too far down. Let's look at this here. Minus 0.3 to plus 0.3 and minus 1 to plus 1 to minus 1. Let's see what that does. Apply. Okay. I'm liking that so far. So we have minus 0.3 and minus 1, and we're going to move this one. We're going to say, it's going to say 0.3 to minus 0.3. And we're going to make this minus 0.3 minus 0.3, and we'll see how that looks. All right, see what I'm trying to do is get this little drawn thing on the board. Ooh, that's not going to draw, is it? Because we have a thing there. So we're just going to have to deal with that, aren't we? Okay. Huh. Okay, so now another last thing we have to do is name all our things. Let's call this therm. Okay, so there's the thermal pad. And we're going to call this one P1. We're going to get rid of that $sign. All right, last thing we have to do is put some text on there. And we have to make it say greater than names. No, just plain name. All right, and we're going to put this into top names. And we're going to make it smaller so the size doesn't look ridiculous. That's too small. I guess that'd be fine. Going to put 2 of those on there, and then we're going to go into this, and we're going to make it change to value, greater than value, and we're going to put that into the value layer. Top value. Okay. All right, now we're going to give it a name. And this is the description. This is the DFN 6-pin footprint. Okay. Now we just save, file, Save. And now we need to make the symbol, okay? We're going to call the symbol what we tried to call the other thing, which is HTU 31D dash humidity. Well, that's fine. And that's fine. Okay, so now what we need is a line, and we're going to just make it as big as it needs to be. All right, and then we're going to put some pins on there. Where'd the pins go? There they are. And we're going to put on our 6 pins. And we're then going to make the ones from the other side. Rotate by 180 degrees. Okay, let's go to the move and move this thing up a little bit. Boom. Okay, now information. We're going to make pin 1. What does that one want to be? That's going to be, pin 1 is SDA. That's the data pin. Okay, and what do we want to see? We don't want to see both. We want to see, I don't remember. Let's say pin. All right, and here we want to call that one, I believe that's ground, isn't it? Yep. And ground is, where did it go? Ground should be, there we go, direction, power, okay. And we want that one just to have the pin available, pin viewed. All right, pin number 3 is supposed to be IC address. Let's just call that one ADD. And just the pin, okay. Here's pin 4 that doesn't want to be pin 6, it wants to be pin 4, and that's the reset pin. Just view the pin, okay. Next one up is pin 5, which is 3.3 volts, is VDD. And let's just look at the pin, damn it, look at the pin. And function, nope, that's not what I was looking for. Direction power, okay. And up here, last thing is the S clock. What do they call it? Yes, SCK. All right. Okay, last thing, we got to put those, well, not entirely the last thing, but one thing we need to do is have greater than name, and that'll go, ooh, that's very small. That's still small. That's good enough. One down here, and they're in the wrong place, damn it. Okay, so information, we're going to go into that guy, and we want that to be in the names file. And this one down here, we want to not say name, we want to say value, and we want to put it in the values file. Okay, got all of our stuff going on. It all looks pretty good to me. Down here in the description, we're going to say this is the, I guess you had it typed down here. You say this is the HTU 31D. Sensor. Relative humidity, comma, temperature. Okay, looking good. All right, so we got our, what's that called? We got our symbol, we got our footprint. Now we got to make the device. There we go. And this is going to be the HTU31D. All right, and let's call that humid. Create new device, yes. Okay, first thing we got to do is get that footprint on there. Where'd the footprint, add the footprint go? There it is, add footprint. That's a symbol. Okay, we're adding a symbol. Put it in the center. And that's all we got to do there. New. Add local package. DFN6 is what we're looking for. All right. Now we're going to do the connecting. And let's see. We want pin 1 to be serial data. Boom. Connect. Pin 2 we want to be ground. Connect. While we're on the ground, let's put the thermal thing. Pinned. There we go. All right, so the reset, hang on a second. Number 3 is address. Address goes to number 3. Connect. Pin 4 is reset. Yeah, that's right. Connect. S clock is number 6. Connect. And voltage DD is number 5. Okay. And at this point, we can give it a description if we wish. And this is the HTU 31D, capital D, relative humidity and temperature sensor. Okay, now we say file save. I hope I saved everything so far. And that should give us something to work with. Okay, now we go back to here, say file new schematic, and we're going to add that thing. Why didn't it open up the add part? Okay, now we're into that. We need to find the AJAC library, and there's our relative humidity sensor. We're going to say OK, and we're going to put it there. All right, so now we have our part, and if we go to the board, we want to create the board. We'll see we have this little part down here, so we can grab the little part and put it on the board, and we can move the size, and we can connect it the way we want to connect it. All right, so that has been a long video, so I'm going to call it there. 20. All right, I hope that has been instructive, and if you have some feedback for me, please leave it below.